Let's try working on the sum of n to the 10 e to the minus n. It's kind of an interesting sounding function. Maybe we should go plot it and see what's going on. All right, here we go. We've got f of x equals x to the 10 e to the minus x. I'm showing it in dots because we should think of it as dots because it's a sequence rather than a smooth curve, but really these dots are spaced tighter than integers, so maybe we should just go back to straight lines or connecting lines. So does it look like this sum is going to converge? Well, it looks like the function is zooming up pretty quickly, so who knows, maybe it's just going to keep doing that forever. But let's think about this function. This is polynomial growth versus exponential decay. Exponential decay should win in the long run. So if we zoom out some and we see, oh, it does increase rather quickly to begin with, but then, and we only care about this for positive x values or positive n values, you could say. Okay, so it takes some zooming, but overall what we're seeing is a surge curve. So we're basically asking what's the area under that if we were doing the integral, or since we're doing a series, we're doing the sum of each little dot's height. So let's go back and ask at least, should that converge? We would kind of expect it to. So let's do the ratio test. I'll set it up by saying an plus 1 over a sub n. Let's do the bottom first. It's usually easier to figure that part out. So that would just be n to the 10 e to the minus n. And then what do we write on the top? Anywhere you write something like this, but anywhere you see an n, write an n plus 1 and protect it with parentheses. So I say n plus 1 to the 10 e to the minus n plus 1. And then let's simplify that. We'll just write this first factor all by itself, n plus 1 to the 10 over n to the 10. And then what do we do with this part? So let's do a side computation there. We have e to the minus n plus 1 over e to the minus n. We can say that's e to the minus, let's distribute the minus here, minus n minus 1 times e, and then we'll bring up this e to the minus n as a positive n exponent. So then we'll add them. We'll get minus n plus, let's try that again, minus n minus 1 plus n, and then we'll get the minus n and the plus n cancels, and we just get e to the minus 1. So we'll say e to the minus 1 there. So overall, we have an plus 1 over a sub n equals n plus 1 to the 10th over n to the 10th times e to the minus 1. We can simplify that a little bit and say, since both of them are to the same power, that makes it kind of easy. We'll say n plus 1 over n to the 10 times e to the minus 1. Now let's ask what the limit is. The limit as n goes to infinity. We'll write it again just for clarity. What is n plus 1 over n as n goes to infinity? That's like 1,000,001 over 1,000,000, 1,000,001 over 1,000,000,000, 1,000,001 over 1,000,000,000, awfully close to 1. Raising it to the 10, still going to be pretty close to 1. So overall, we're getting 1 times e to the negative 1, which is exactly 1 over e, which is roughly 0.367-ish. Should check that. Okay, so that's L. And then we can say, since L is less than 1, the ratio test says what? It says that the sum converges. So in one case, we got an L value of 0 up here, and that tells us that the sum converges. Here we got an L value of something still less than 1. That says the sum converges. You never know what will happen on the next example in the next video, though.